Vanakkam, hi and Selamat Sejahtera. Myself, Shashi Kumar, Kumar, third year Diploma in Electronics Engineering. Today, I would like to present about my final year project, Greenhouse Sensing Station, or also known as GHSS. But before that, let's have a detailed presentation about GHSS. Come on. Welcome to my presentation slides. As I mentioned before, my project's name is Greenhouse Sensing Station under the supervision of Dr. Adi bin Muhammad Kafi. Without further delay, let's move on to the introduction part. Before we get to know about what is a greenhouse sensing station, let's get to know about what is a greenhouse and what is IoT. A greenhouse is an urban farming approach provides farmers with an option to provide optimum cultivation conditions by offering a controlled environment according to the crop's requirement. Now, what is IoT or Internet of Things? It is an environment in which simple physical objects are made capable enough to get access through internet for collecting and transferring data over internet without any intervention. What is a greenhouse sensing station? It is a system in which various sensors are used for monitoring various parameters such as temperature, pressure, humidity, and etc. with the aid of IoT. Moving on to the problem statement of my project. In today's normal greenhouse, many parameter measurements are required to monitor for the good quality and productivity of plants, which come into play like temperature, light. But due to a lack of knowledge among farmers, they are not able to perform their activities with accuracy. They usually monitor the plants on the basis of their own observation from the past and with their gut feeling, which may lead to unexpected results most of the times. But these systems are based to perform such activities that are to monitor the system from a particular place which would take care of an environment inside the greenhouse. The other important part of this project is that it can notify the user immediately on the inappropriate surroundings in the greenhouse. The objectives of my project are to design a smart greenhouse sensing station with the aid of IoT, to create a safe environment for plants in the sense of temperature, humidity, light intensity, and smoke-free, and finally to monitor the plants and notify any mishaps in the greenhouse constantly for greater growth of plants. The literature review of my project are two. First one, Aloza Dele WS has specified in their paper about the microcontroller-based greenhouse control device used in the automatic control and monitoring of equipment and quantities such as screening installations and other quantities in a greenhouse. Secondly, Kirti, Dr. G.N. Kondaramaya has explained GSM, Global System for Mobile, Cloud Computing, and IoT, Internet of Things based electronic system, its design and implementation for sensing the climatic parameters in the greenhouse. Next, the scope of project. This project focuses on the development of greenhouse sensing station among the farmers with easy implementation. The concept of this project is monitoring the temperature and humidity by using DHT11 sensor, LDR sensor to monitor the light intensity in the greenhouse, and MQ2 to monitor any combustion gases in the greenhouse. Node MCU, which is the brain of this whole project, has a built-in Wi-Fi module by receiving and transferring data from sensors to online. These data will be seen in an internet website such as Cayenne or Google Firebase, and also a mobile app, Cayenne App, through smartphones. This is the block diagram of my project. As we can see here, there is a node MCU which is given a power supply, temperature sensor, humidity sensor which is DHT11, LDR sensor, and also MQ2 sensor. All these are inputs, whereas the output will be the IoT cloud data. This data will be monitored in the Google Firebase web and also Cayenne Web and App. Next, the operation of block diagram. First of all, sensors. Sensors such as DHT11, LDR, and MQ2 will detect its respective conditions in the greenhouse, and it will be moving on to a node MCU. All the sensor data will be transmitted into the microcontroller to send it to Cayenne Web or Google Firebase. And finally, the cloud data. The results can be seen on the Cayenne Web or Google Firebase. A notification through text message and email by the Cayenne app will be sent to the owner to trigger if there is any unsuitable environment detected in the greenhouse. Let's have a look at the circuit diagram of my project. I've did this circuit diagram using easy EDA software. As you can see there, it is the schematic circuit design of my project, which contains the node MCU, LDR, DS11 and also the MQ2 gas sensor. And this is the PCB layout of my project. Besides, the prototype of my project GHSS. As you can see there, on your left that is the front view and on your right that is the back view. And there is the right view and also the left view of my prototype, and not forgetting the top view of the prototype. Before we further move into this presentation, let's have a demonstration of this prototype. Let's take a look at the prototype. This is my prototype, which has GHSS, which means Greenhouse Sensing Station. This is the whole view of my prototype. Let's take a look at the components in the prototype. This is MQ2, which will detect the smoke combustion gases. And this is LDR, which will detect the light intensity. This is node MCU, which is the brain of the project. And finally, the DS11, which will sense the temperature and humidity inside the greenhouse. This is the Google Firebase real-time database webpage. Here we can monitor all the 4 parameters of sensor data. The first one is air data, which is from the MQ2 sensor. 1, it means there is no combustion gases detected. Second one is H humidity 67%. Third one LDR data, the light intensity 32 voltage, and finally the temperature 29.05 degrees Celsius. This is the first way to monitor all the sensor data through web page. Let's move on to Cayenne method. Welcome to the Cayenne Web. This is the Cayenne Web looks like. This is how the Cayenne Web looks like. And here we can monitor all the sensor data such as humidity in percentage, temperature in degrees Celsius, smoke sensor in digital output 0 or 1, light intensity in volts, and also we can switch on or off the LED in the node MCU. We can also download the raw data from Cayenne Web by having the complete timestamp. This is the data and we can download it from here. Next, we can also set some triggers and alerts whenever we need to set a limit for temperature, humidity, smoke, and also light intensity. We can also switch on or off the notification or the triggers in the Cayenne Web according to the environmental changes in the greenhouse sensing station. This is one of the most important features in this Cayenne app or web. Now let's take a look at the Cayenne app and the notification system. This is how Cayenne app looks like. These are the sensor data from the node MCU that have been received. Although it just looks like the Cayenne Web, but Cayenne app is much more easier to be installed in your smartphones, and it is easy to operate the whole system by just using your smartphone. We can also set the triggers, switch on or switch off the triggers using this Cayenne app. Now let's look at the notification part of this Cayenne app. I would like to take an example
which is the fire alert, because it is much more easier to show a demonstration. If smoke sensor is off, which means when the smoke sensor detects the combustion gas, then it will notify me through email and also SMS my number to my number. Save it. Now the fire alert is on. Let's test the notification system. Now I'm creating combustion gas inside the greenhouse. Once the combustion gases has been detected, it will send a notification into my phone through Cayenne App. As you can see, email and the channel 4 was detected and sent a notification to the owner instantly.
Back to presentation slides. Now I would like to do a discussion about the project just now. Firstly, Google Firebase. Google Firebase can be accessed by everyone through online by just searching for the project name. Secondly, Cayenne Web. Cayenne Web can only be used by using one type of data information but no restrictions and can download raw data anytime, anywhere. Third, Cayenne App. Cayenne App can be installed by everyone in their smartphones and log in using the same information in the web. It can notify multiple users instantly through text message for registered phone numbers and email. Now I would like to share the complications I faced during this project. First complication was Android Studio for Google Firebase. I decided to create an app in Android Studio for Google Firebase, but I couldn't do it, so I used Cayenne instead. Secondly, limited analog output in NodeMCU. MQ2 and LDR sensor needed analog output, so I decided to change MQ2 to digital output. Finally, Proteus 8 Professional inoperative in my laptop, so I used Easy EDA online software as a replacement. Moving on to conclusion. This project describes about the various aspects of greenhouse monitoring using IoT. Farming activities even in urban zones are on an ascent or laid in remarkable structures. Innovative advance makes the agrarian area develop high, which here is made by the IoT, Internet of Things. The IoT will be playing a great role in changing the day-to-day life experience. The proposed project could be beneficial as it will help in advancing the assets in the nursery, and right now, limited number of parameters will be used in the project, but with the further advancement, more number of parameters could be added for boosting the production. In future, by building up a versatile application for IoT framework makes more adaptable to the people groups. Finally, I have some recommendations for that project. The notifications in the smartphones from Cayenne with the name of the parameter instead of number of the channels. Secondly, I would like to recommend to insert relays in the system to control the environment in the greenhouse while monitoring without any manpower. For example, artificial lights for LDR sensor, fan for temperature and humidity, and finally buzzer and sprinkler for fire smoke. That's all for now. Thank you for listening. Thank you.